Hello all, let's start chapter 5. Chapter 5, 5.1 and 5.2, we are talking about discrete probabilities. Discrete means countable or finite. That's the meaning of discrete probabilities. We are dealing with the probabilities that they are countable, they are finite. Like the examples that we did in the past in the chapter 1 about discrete data is a data that it's countable. Like on that time I give you the example of number of eggs, correct? You can count the number of eggs if you go to an egg farm, correct? It's impossible to say, oh, this chicken gives me 2.5 eggs. There is no decimal, they are countable, right? Usually these kind of data we call it what? Discrete. When it comes to probabilities, it will be a discrete probability. What will be a good example for a discrete probability? For example, dice. Dice will be a good example of a discrete probability because a dice has 6 sides. Correct? And in these sides you have numbers 1, 2, 3, 4, 5, and what? And 6. When you look for the probability of each one of these, for example, the probability of 1 is 1 over 6. The probability of 2 is 1 over 6. Correct? These types of probabilities, we call it discrete probabilities. First thing, as usual, what we do here, let's talk about some vocabularies that we know we need here, right? I will write here some vocabularies for you. And the first one is random variable. What is a random variable? A random variable, or if I put a good definition for you, a variable x, usually we use x for our data, correct? And x is a variable x that has a value for each outcome of a procedure that is determined by chance. We call it a random variable. For example, when you are rolling a dice, correct? Your variables are, in this example, all these numbers from 1 to 6, each one of them is x. Correct? When you are rolling a dice, that's your procedure. You are rolling a dice. Correct? What is the chance that we have the probability of 2 getting a 2? It's 1/6, correct? That's what this definition is about. We call it a random variable, correct? The second, let's talk a little bit now about probability distribution. We already know what is a probability distribution means because we did histogram Uh, on that time, we were talking about data distribution, correct? Now, same thing we do with our probability distribution. What is a probability distribution? It is a table. It is a table that gives the probability, that gives the probability for each value, for each value of a random variable, of a random variable. Right now, I'll use this example of dice, but of course, I'm not going to graph this because all the probabilities are the same, but soon I'll do another example with weighted dice. I'll cheat a little bit, and that one we will also graph the histogram, correct? This is your data in a dice, correct? If this example is about die or dice, your x is 1, 2, 3, 4, 5, or what? Or 6, because you have 6 sides. What is the probability of having 1? Is 1/6. Probability of having 2 is 1/6. Probability of having 3 is 1/6. 4 1/6. 5 1/6. 6 1/6. Correct? You see that probability distribution, right? This is your P of X. This is your probability, right? Probability distribution is actually a table that shows for us the probability of each random variable. Correct? Each one of them, 1, 2, 3, 4, you can call them random variable, all of them, correct? We call these random variables. Random variables, correct? Now, another definition that I want you to learn before the next example that we will do the histogram is discrete random variable. Discrete random variable. A definition, a variable with a countable or finite, because the meaning of discrete is what? Countable or finite. Number of variables we call it discrete random variable, correct? In example above, which I did the dice, all of them is countable, all of them is discrete because we can count them, correct? 6 sides of a dice, or the example of having a deck of cards. You have 52 cards in it. It's countable, correct? It's discrete. Opposite to this, continuous. Random variable. It's a variable with an infinite number of possible values. good example, measurement. Measurement. That will be a good example of countable. This is not the topic of discussion of chapter 4. Continuous, we will discuss it in chapter 6. Correct? I did this example so many times in the class that measurement is a good example. Look, if you just think about two close numbers, for example, between 1 and 1.1, how many numbers are between 1 and 1.1? We have infinite numbers. Correct? For example, 1.01, 1.001, 1.000000001. You have infinite numbers between two really close numbers. That's why they are not countable. They are infinite. If I ask you how many numbers are between 1 and 1.1, you cannot say 10, you cannot say 50, you cannot say 1000. There is infinite numbers between these two. That's why a measurement is a good example of continuous random variable. We will cover this in detail in chapter 6. Now let's learn how to do the histogram for probability distribution. How to draw a histogram from a probability distribution. Two things in histogram that I also explained in chapter 3. Again, I want to write it down here for you. Your horizontal axis what you put in your horizontal axis, values of random variable. Values of random variable. Always you put that one in your horizontal axis. And your vertical axis, you put your probabilities. Like in chapter 3, your horizontal axis was your data. The vertical axis was the percentage. Correct? Here, your vertical axis is your probability, horizontal, your random variable. To show you a good histogram, I'll do a little bit cheating here. I'll give you the example of a weighted dice. Correct? Example of what? Weighted dice. For example, I'll give you a dice that I did cheating in it and it's weighted. Correct? Your variables are the same. 1, 2, 3, 4, 5, 6. Even it's weighted, but variables will be the same. Correct? The only thing that I do, I'll change in the probability of happening. Correct? For example, because it's weighted, I want you to have 5% of time when you're rolling this dice, get 1. 15% of time, when you roll a dice, you get a 2. 35% of time, you will get a 3 when you roll a dice. 30% of time, for example, I want you to have 4 when you roll a dice. 10% of time, you will get a 5, and also 5% of time, you will get a 6. It's a weighted dice. It's happening. Some people does this. Correct? When you roll a dice, immediately you see, oh, I'm getting a 3. Again you roll, you get a 4. Again you roll, you get a 3. Again you roll, you get a 4. Correct? Because it's weighted. Correct? Now I want to do here a probability distribution or a histogram. Few things, few notes that we should remember always. Actually, there are rules in your book. I put them as a notes. Your probability must be greater equal than 0 or less than equal what? 1. We know this. Each probability, please memorize this. You need it all the time. Each probability should be between 0 and 1. You see all these numbers on the right side of this table? All of them is between 0 and 1. Correct? You cannot have a probability of 2. You cannot have a probability of 3. And you cannot have a probability of negative. Correct? Because there is no negative probability. Rule number 2 or note number 2, the sum of your probabilities, which is the right column here, always should equal to 1. 1 means for us 1%, right? 1.00. Correct? If you add the right column, you will get 1. 1.00. Is it happening all the time when we do probabilities? No, we will be off a little bit. Maybe we get 99.99 or 1.01 or 0.001. You can be off up to 1%, not more than that. Correct? Now, I want to draw this histogram. The table is there. I already explained how to draw the histogram. You need 2 axes, vertical axis, and you need your horizontal axis. And horizontal axis, x values. How many of them I have? 6 of them. 1, 2, 3, 4, 5, and 6. Correct? I'll mark in between. I like to mark it in between because I want to show that this bar is actually 1. All of them. This is 2. This is 3. This is 4. This is 5. This is 6. I need 6 bars. On the vertical column, probabilities. Correct? The first one is 0.5. Even I'll recommend you that when you do histogram for people, show the percentage. You can put instead of 0.055%. Correct? Because some people, they don't know what does it mean 0.05. It means 5%. You can do that also. Correct? Then I have 10%, 0.10. Then I have 15%, 0.15. I have 0.20. I have 0.25. I have 0.30. And the last one is, I think what we need is 0.35. What is the probability of getting 1? If I draw now my bars, the probability of getting 1 is only 5%. Here you go. This is your first bar. Nicely drawn. What is the probability of getting 2? Is 15%. This is the probability of getting 2. That table shows actually everything, but why we do histogram? Because some people, they are not good with tables, but they are good with pictures. They can see it here. What is the probability of getting 3? The highest, 35. And trying to draw straight lines. You can use ruler or ATM card at home. Correct? Probability of getting 4, the probability of getting 4 is 30%, lower than this a little bit. Probability of getting 5 is 10%. And probability of getting 6 is 5%. If you look carefully to this histogram, easily that you see that every time that you are rolling a weighted dice, you will get 3 or 4. Because it's designed that way. It's weighted that way, that you should get 3 and 4. Okay? You see how much the probability is high? If I ask you a question, when you roll a dice, do you ever get 1 or 6? The answer is yes, not no. Some people says no, 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 no. No, it's yes. You see, still you have a chance of 5% here or here. You are getting those 2 also, but the chance is very low. Correct? This is how you do a histogram for a probability distribution, and that this lecture was you were covering your 5.1 and 5.2. I'll stop the lecture here and see you all in lecture 5.3.